everybody, and welcome to the BRLSI Business and Economics series. As you well know, I'm Andreas Wasmuth. I'm the convener for Business and Economics at the BRLSI, and I'm delighted to welcome you to another lecture via Zoom. It's always quite interesting when we do the Zoom lectures because some people then unmute themselves and show their video, and if you could refrain from doing so, that would be really, really helpful. I won't take up too much of your time. I just want to put in a few things of process as far as Zoom meetings are concerned. One is that if the technology goes completely wrong and you lose connection, the only thing you can do is actually re-click on the link and it will let you back into the meeting. I think that's the first thing to say. The second thing to say is that we are actually recording this lecture today, which is what you would have seen in the preamble on Eventbrite. So if you do not want your image to be shown throughout the lecture, then obviously keep your video off, but you can still ask questions in 3 different ways. You can do it if you're happy to show your face on the camera. You can do it on a tradition of just raising your hand, and I will pick you up at the end of the presentation during the Q&A session. You can also raise your hand electronically via Zoom. There should be something in the participants bar. There's 3 little dots, and you can click on that and raise your hand that way. And the final way is to actually just ask a question through the chat room at the bottom of the app. So I think those are the 3 ways of doing things. I think Jennifer will take about 45 minutes for her presentation, which will leave us lots and lots of room for Q&A. And especially since it's such a very interesting and topical and really cutting edge technology that she will be talking about. Again, I've got Jackie Wilkinson on the thing. Hello. Would you mind just taking your camera off for the presentation and then put your camera back on when we get to the Q&A session, please? That would be really helpful. Good. Well, without further ado, I would like to introduce you to the star of tonight, and that is Jennifer Johns. I'm delighted that she's actually with us today to talk about 3D printing and the next industrial revolution, and that's a question mark behind it rather than exclamation mark. So I think you might already guess some of the kind of things we might be covering. But I'm delighted to look at this cutting edge technology. And Jennifer gained her PhD in Manchester. She was a senior lecturer for 13 years at the University of Liverpool, a senior lecturer in international business and economic geography, and has recently joined the University of Bristol as associate professor in international business, where she performs a multidisciplinary, interdisciplinary research across different industries, different sectors, and also including different disciplines. So today's talk is about 3D printing, but she's also been heavily involved in supply chains and other sort of international elements of business. So it's with great pleasure that I give you Jennifer Johns. Over to you, Jennifer.
Thank you very much, Andreas, and welcome everyone. When I agreed to do this talk, I thought I'd be coming to Bath to see you all. So I'm delighted to be able to see you. I just wish it was face to face, but I'm sure we'll manage perfectly well this evening. So thanks for joining us. I want to talk about several things around 3D printing tonight. I'll talk in a moment about how I ended up doing research on this, but I just thought I'd explain and outline what I'm going to go through in the 45 minutes when I present tonight. Really, well, the first thing I want to talk about is what all's the fuss about. And I'll go through some of the rhetoric that we have around 3D printing that I'm sure you've become aware of. We'll think a little bit about what actually 3D printing is, which is not a simple answer, as I'll explain, and then talk about the myths surrounding 3D printing. And I'm going to talk through my opinions based on evidence, based on research about some of those myths and what we might want to question about them. And several of those are really debate points, which I welcome you to disagree and challenge with me in the questions. There's no right or wrong answers, I think, around this. All I can do is give you my perspective based on the work I've been doing. So I want to present to you kind of a realistic picture then of what's happening in 3D printing across the different types of 3D printing production, which I'll also explain. Kind of woven through that will be the real general question about what are the futures that are facing us as a result of use of this technology. So I'm going to show this video now, which we've tested and does work, but I'm going to mute it. It's going to show you some plastic 3D printing under time lapse, so going much faster than it does in real life. But during that time, I'll just tell you a bit about the research I'm doing and how I've got there. So I'll mute this, and it's going to show a 3D printer. This actually is going at the speed that it does in reality. You can see the bed moving, and that's the speed at which it printed, and this is now the faster time lapse. So Andreas introduced me, and I teach international business. My background actually is a geographer. So I do work on globalization, looking at firms, how they internationalize in their operations. My PhD was looking at creative industries, at the film and TV industry, looking at the power relationships between different suppliers. And much of my career I've spent traveling abroad, interviewing firms and looking at different industries and understanding their dynamics. I then started working in a management school, moving from a geography department, and became interested in entrepreneurship and worked with a colleague looking at makerspaces and fab labs, which, if you've heard of them, these are democratized spaces where people can go and use digital technologies, one of which is 3D printers. So I did some work on that, but then became really interested in the technology itself and became much more aware of the more dynamic changes that were happening in industrial 3D printing. So I went from the smaller scale machines that you can put on your desktop and use at home, right through to £500,000 machines that are used in industry. So I secured funding to do research, funding by the British Academy, to do research on industrial 3D printing. And some of those findings will come out in the presentation tonight. That involved going and speaking to 3D printing manufacturers, the people who make the machines, in the UK, Germany, and the US, in the days when we could travel. And also looking at the OEMs, the original equipment manufacturers, the big firms that are using these kinds of technologies. So firms like Airbus, BMW, GKN, all the big, the Formula One companies. So I did some really exciting interviews and got to go to some really interesting production sites. So this has given you a brief introduction then into this kind of building up of printing. I shall pause this and move on to the next slide, because I wanted to show you this short video by Ultimaker. Ultimaker are a Dutch 3D printing company, and they're quite famous because the three men who set up the firm developed the first Ultimaker in a fab lab in a makerspace. So they've got quite an open source democratic approach to how you print, and they have made a multi-million-pound business that sells globally through Ultimaker, and their international distribution is through the UK, just north of me here in Chorley. So this is just one of their promotional videos, which might match with some of your expectations about what happens when we 3D print. So that shows for us then a vision of Ultimaker and how they think we're going to use their machines. Now, you can see the layers being built up to build that spaceship. And this is how we can understand the difference of 3D printing and other conventional manufacturing methods. And this diagram shows for you, we have formative manufacturing, so injection molding, for example, and subtractive manufacturing, where you're chipping away at something in order to create the shape you need, and additive manufacturing, which is built up using layers of material. And this isn't a particularly new process. Stereolithography was developed in the 1980s. So we're not talking about a relatively new process at all. And the technology's taken quite some time to develop, to the point where we have these promotional videos from automakers showing us a very smooth and easy process, which in reality, many of us would struggle with either knowing the software, how to design in the software, and how to print. And that showed him in that room as if it took about an hour to print that spaceship. In reality, it was probably about an 8-hour print job if it succeeded, and many of the prints fail. So we're presented with this rhetoric around this kind of plug and play, this very easy technology. And some of the realism I want to bring into the presentation today is about how we're not quite at that point yet, and whether we will be in the near future. So moving on then to these claims, there's 3 that I want to focus on today, and these kind of mirror some of the things that you will have heard in the media and continue to hear in the media. The first is that we will all have 3D printers in our homes. So we'll be able to source designs and print at the flick of a button whatever we need and whatever we need to consume. So this is really buying into some of those bigger ideas around a kind of Star Trek replicator machines that can give us what we want on demand. I'm going to spend some time talking about why I think that might not be particularly realistic tonight. The second claim is that 3D printing will replace traditional manufacturing techniques. So a lot of the rhetoric in the popular media and in academia is that 3D printing will revolutionize manufacturing, and that we won't need to use traditional manufacturing methods. And that such is the scope of the capacity of the additive manufacturing that we wouldn't see a rationale for using traditional methods. Additive manufacturing has got several advantages over traditional manufacturing. Because we're adding layer by layer, it enables much more complex geometries, as they say in the industry, a lot more complex shapes that can't be produced using traditional methods. So this means that there's the capacity to make savings in terms of weight, for example. Also, instead of manufacturing several parts that you'd put together, you can manufacture one part at the same time. So there's time savings. But also there's the ability to customize the production. So a machine can print off the same product but have a different serial number or make slight modifications to each of them. So you're completely changing your understanding of the economies of scale of production. So the people who buy into these, the capacity of additive manufacturing, are very enthusiastic about how this could change how we manufacture goods. The third claim is related to this, and that is that not only can it change how we produce and consume goods, but it may also change where we produce them. So if you're not producing millions of the same widget in China, do you have to export your production to the Far East? Are you so driven by low-cost economies? So there's a lot of rhetoric that's become quite highly politicized that I'll come on to talk about in terms of a perceived shift in where goods and services are manufactured. So why do we have this hype? We see a lot of this, and you see it in the title of the talk, of a talk of a shift towards a new industrial revolution, a fourth industrial revolution, as we're coming out of the third. Really signaling this sea change in how goods are manufactured. That's because there are many successful ways in which additive manufacturing, 3D printing, has been adopted in the production of particular goods, and I'll talk about some of those today. And they've completely changed how those goods have been produced, which is leading to questions about, are there other goods that can be completely changed in terms of how they're produced and where they're produced. Industry is itself looking for what the next big thing is in 3D printing. and it hasn't quite found it yet. As I mentioned, this potential for increased customization of products and potential for users to make their own designs. So in academia, we hear this term prosumers, which is merging of production and consumption. So people are producing their own goods and they're designing their own goods. So you're collapsing that relationship between the final manufacture and the design, and the idea that a single individual can do all that for themselves. And that becomes liberating, it becomes enabling for people to manufacture their own goods and to customize them. And we can think that there's some quite things that we would quite enjoy about this. How about printing shoes that fit our feet perfectly, or gloves that fit our hands perfectly, or clothes, for example, or even just being able to choose what color we want something to be in. There's also around a bigger picture around this. Is 3D printing is often assumed to be helping to agendas around carbon emissions and sustainability agendas, with this kind of feeling that the world is full of cheap plastic manufactured goods, and that if we were producing more customized products, would there be less consumption? I must note, though, that with industry, there's a very cautious tone around these claims around carbon emissions and sustainability. The machines use a lot of electricity. There's powder machines, which are bad on lungs. You have to have protective equipment. And so the automakers using plastic. You can get recycled filament, the plastic that you saw going into the back of the machine. Much of the claims around sustainability are actually about relocalizing that production rather than the production itself being any less resource intensive than traditional manufacturing. But there is a debate around the circular economy, the idea of reusing goods, recycling them, and keeping more localized systems of where we source the resources we need to produce things and where we consume them. The final point has become more important lately, and this is where 3D printing can be perceived as a potential solution to some of the quite significant problems that we're anticipating as a result of political change around how goods move across international borders, this kind of drive towards self-sufficiency that we're seeing in the UK and in the US, and to reduce dependency on imports. And here we're seeing a lot more talk around how 3D printing can help us produce what we need within our boundaries. So this speaks very much to my expertise in geography, and around the idea that 3D printing could help reduce this dependency on long supply chains that are particularly vulnerable. And obviously COVID-19 has increased our awareness about some of the vulnerability of our supply chains. And I've been doing some work recently on how firms in 3D printing industry have been responding to COVID-19. Now, I want to paint a picture to you really of kind of two sections of the 3D printing world that are interrelated but are quite distant, but due to technological change are increasingly coming together, and I'll explain how. On one hand, we have domestic 3D printing. So these are machines that we can buy relatively easy and use at home, right up to the industrial additive manufacturing that I was talking about, where we have very large, very expensive machines operating in factories. The domestic 3D printing has become very much driven around sharing economies and people sharing designs and producing and making goods for themselves. Whereas industry has a much longer history where there's innovation happening in relation to producing at a much larger scale. I started working in domestic 3D printing where there's a bit more research. There's comparatively little research outside engineering on industrial 3D printing, and very few researchers are doing on the ground work, talking to people in industry, which is why I've been doing what I've been doing. I have a number of other roles outside academia. I'm an academic advisor to Reshoring UK and the GTMA, who are a tooling trade association. And I'm also a committee member, and I speak regularly to the the Additive Manufacturing Users Group, which is a US-based global organisation where users and developers of the technology get together. So as well as producing in academia and writing in academia, I also write for industry. And some of that's going to come out in what I'm going to talk to you about today. So if we look at domestic 3D printing starting in the home, we've seen the cost dropping quite dramatically. I've used the example of Automaker here. Other printers are available. I don't work for Automaker. I use this example because it's relatively widely sold and is considered to be quite easy to use. So you can see here around £2,000, depending on whether you're paying VAT, which makes this within the range of somebody who's going to use the printer at home. And we have hobbyists who would use this machine. And it's quite a good entry into 3D printing. You'd use the software to develop your designs, and there's a whole wealth. The Internet of Things can provide all manner of designs that you can take and share with other people. And you might typically start by printing a 3D printed chess set, for example, but people then go on to use this to develop things. They might use them for prototypes if they owned a small business, but mainly for people to produce domestically on. Now, we see a lot of rhetoric around how we will be printing what we need for ourselves in our homes, but I put these images up to encourage us to think about the whole wealth of tools that are available to us at home and the kinds of things that we can do ourselves. We have a tool shed here with lots of woodwork equipment. We have a lathe, we have a sewing machine, and we have some vegetables. And I mean, it speaks to, I think, COVID's maybe perhaps made us all think about how we could do more at home. But having these tools doesn't necessarily mean that you're going to be able to use them or have anyone to show you how to use them or have the time or the inclination to always use them. I have a sewing machine and I do sew, but I don't make all my own clothes. So I think that we have to be quite cautious when we think about how 3D printing at the moment is something that all of us are going to be able to access. Numbers are increasing of people buying machines, but I don't think there's going to be a massive rush for all of us to be going and doing it. One of the things that has become quite interesting about domestic 3D printing is if the machines do become a bit more accessible, a bit more plug and play, a bit more like the Automaker video, where you could just upload something and print it, getting more into the realms of your everyday user being able to use them. We can see that there will be room for us to print some of the things that we need. Some things could be quite transformative in the sense of spare parts. If something small that you're using that's made of plastic breaks, you could be able to print that yourself, saving you having to have it posted to you or going and buying it. This means that there's been a lot of talk about this term distributed manufacturing, moving away from the idea of highly centralized production where things are made in the millions, potentially thousands of miles away and then shipped to us. And that actually there's models where if we have more localized 3D printing in smaller networks, that we might be able to access this kind of smaller production as and when we need it. So, I mean, example could be, we could be looking at something like the post office network, where you have that kind of localized production, where you have something that could be within 2 or 3 miles of you. When I was doing work on makerspaces, I was working with the Fab Lab. This is a network of makerspaces that came out of MIT in the US, which has the aim of getting people to use the technologies to enable entrepreneurs, people who are out of work, to get people with those digital skills to use these spaces for free. So I did a lot of work for them. I wrote their guide to how to set up the Fab Labs. And they were involved in a very interesting experiment in Barcelona, where the government, the local city government, came up with a scheme to have little districts, each with a 3D printing centre in them, in order for people to access these services and to print the kinds of things that they needed. I wish I could be more optimistic about what happened. In the end, the Fab Lab fell out with the government and nobody's really sure what's happened since. But you can kind of see that there's also a government interest in creating more localized production. And really this sounded a bit futuristic until now, in the context of COVID, where many of us are leading much more localized lives, that this could potentially begin to resonate a bit more than it might have done before March this year. On the other hand, I'd also offer a counter argument, is that with logistics being as sophisticated as they are, there's no reason why 3D printing couldn't remain centralized. So we could still have big printing centers which dispatch to customers. And we have some of that now. We have 3D hubs is available on the internet. You go in and it'll find you somebody that's going to print what you want and they'll send it to you anywhere in the world. And you can choose and you get a quote all online, don't speak to a human, and the goods will come to you. So really, it may be that the status quo wins and that we see that firms who are currently managing our logistics continue to do so, even though they're using this transformative 3D printing technology. And this is why suddenly we begin to see firms like Amazon, DHL, UPS, all becoming interested in investing in 3D printing because they want to manage this logistic process. In a sense, they don't want individuals or small communities to regain control of that process. We see this tension then between these possible futures with the domestic 3D printing production. But I think that actually it's more likely to be outside forces like peak oil running out, shifts in logistical capacity, environmental, medical and political disruption of supply chains will probably change those supply chains, and then there will become a role for 3D printing. So I'm just pulling up now this, I just found one for you out of my own files from UPS, where we see the huge US logistics firm setting up a distributed on-demand manufacturing networks that's linking their global logistics network with 3D printers, working with Fast Radius, they're a US 3D printing manufacturing firm, with a 3D printing factory. And this was a sizable investment and they've continued to invest in this. So when I talk about the 3D printing industry, the start of my research was very much on who makes the 3D printers. There's a whole range of other people involved in this now, including logistics firms, which may impact on the experience for us of 3D printing in the future. So I want to turn now to my expertise in industry and industrial manufacturing. 3D printing in industry is called additive manufacturing. So I apologise if I've already been using these interchangeably. It causes some confusion, particularly in the press. Industry likes it because I think it distinguishes them from what they see as the production of small bits of plastic on domestic machines, because obviously what they do they consider to be much more serious. So if you look at the picture on the right, this is the report that I published just in March, just as COVID was hitting, based on the empirical research that I'd done with the companies in the 3 countries in the US, UK and Germany, which has been very well received by industry and has led to me being commissioned to write all kinds of magazine articles and do talks, which has been fantastic. Which also made me have some dialogue with industry to make sure that what I was talking about in relation to additive manufacturing made sense to them. Now, I mentioned how 3D printing itself isn't a particularly new process. It has been used in many sectors for several decades for prototyping. So if you think of any industry sector with any large firm globally, they would have had a part of their production facilities where they would have had 3D printers. And they would have used those machines in order to prototype, to print a quick version of whatever product they were designing and producing, to test it and to improve it. And 3D printing here has revolutionized the time it takes for products to be finally produced and to go through that innovation process. And it means that it doesn't require any tooling, and it's reduced costs in terms of the time it takes to produce things. So the big firms are used to working with 3D printing machines. This isn't new to them. What is new to them is what the future holds in terms of the scope of how they continue to use additive manufacturing. So cost and speed are the limiting factors. So that keeps much production in low volume. So we're talking normally production in the low thousands, getting nowhere near the millions that you're producing in injection molding. So when I go on to talk about some of the sectors that have been very successful, we'll see here that their demands override these current limitations around cost and speed. I spent some time with some Formula One racing teams. They use 3D printing extensively in prototyping because they don't have to worry about cost so much. They have the money to do it. And they've increasingly been using 3D printing now to actually produce the parts on cars and in critical functions, not just on small plastic parts, but part of the workings of engines, so in plastics and in metals. That's because the industry has matured now, and there's been much more work done around the productions of standards and testing, and less concerns around the reliability of the prints. There are still some, but there's less now. So current debates in the industry, when I go to industry conferences and speak, they're very much talking about how can we be printing in larger volumes. So, for example, the automotive industry are very keen to work out, and they're demanding the printing machine manufacturers make improvements in speed so they can produce in larger volumes. And we are past that tipping point now. We are seeing many more products being made using 3D printing, which we as consumers may not be able to see, but they're certainly there. Now, I pull up this table a lot. I show my students, and I thought it'd be quite useful for us tonight, mainly because I want to highlight for you how many different processes there are in 3D printing. You can see vat photopolymerization, material extrusion, material jetting. These are all the ones running across the top. Binder jetting, powder bed fusion, and direct energy deposition. And you can also see the different materials and the different ways that those processes can also be used. And under each of those different ones, we have different firms that are offering those different services. So in one of them here, you can see Automaker, we have Formlabs, and these can be divided into plastics and into metals, ceramics, wax. The industry is mainly dominated by plastics and metal. We see most expertise in metal in the UK and in Germany, and the US tends to lead on plastics. But we have seen other countries. There's expertise in Japan based on their former and existing expertise in normal printing, printing on paper, and also investment in countries like China, and huge investments, and also in Singapore. So when we talk about 3D printing, it isn't one process. It's a whole different array of different processes. And the industry is very fragmented in terms of who offers those different services. Now, these are all based on the slow development of the technologies over time. But as you can imagine, this creates a very complex picture for firms who are looking to produce things and might not necessarily know which are the right ways in order for them to access this technology and which is the right one for them. So in the UK, we're very lucky to have a centre in Coventry where you can go for independent advice if you're a company, advice on which machines would suit you best. Yeah, in other countries like Germany, for example, you would go to one of the big firms like EOS or SLM, and they would sell you one of their machines. So we're lucky in the UK to have this independent centre, but it needs more funding, which I'm sure comes as no surprise. So this development of different technologies has led to some quite dramatic stories, which are probably your starting point, and which is probably where you expected me to start in my talk. The strength is in several sectors. Hearing aids, nearly 100% are now produced using additive manufacturing. And this is because every single hearing aid is customized. It's made for the individual. So the cost, every piece is a one-off. So the extra cost of additive manufacturing is outweighed by the ability to produce exactly for that person. This has happened within the last 15 years, and there's hardly any production of hearing aids using any other method. We're also seeing in the medical sector, there's a whole range of different things that are implanted into the body, like hips for hip replacement, dental implants. The picture on the far bottom right is metal printed on an EOS machine for teeth. And this is where additive can produce these personalized production relatively quickly. And it's not using up too much of, this is using a powder process, not using up too much because they're very small parts. So you can print many, many in one print on one print bed. So these small things tend to suit additive manufacturing. And what's interesting about the case of dental is that we're seeing one of the few examples of a big transformation in where they're being produced. So in the past, a dentist would send the scans to an operator who would manage that process in a centre, usually some distance away, which would then be shipped to them when they're finished. What's now happening is that 3D printing machines are coming into the dentist surgery. So they're able to actually print what they need on location, which is completely collapsing that supply chain. Of course, they still need the expertise, and they will have somebody come in order to do that for them. Dentists aren't suddenly yet able to print all of their own implants. But this is one example where we are seeing a distinct geographical shift, and because there aren't many, and I've been looking for them, and this is one of the few, the way it's become a really big success story in that sense. Now, another area where we think that additive is going to make a real difference is in spare parts. The reason for that is that firms often spend a lot of time and money storing spare parts and shipping them out. Or the customer waits a long time, think of a part for your car, and the garage says, oh, we've got to wait for it to come in, and it comes in. We're thinking that being able to produce, say the garage can print it, that reduces time for the consumer, and it also reduces warehousing and logistical costs. So this is expected to become quite big in terms of 3D printing because of the cost savings. It also means that legacy parts, you can scan parts and then print them using 3D printing. So actually you can just store designs of your parts. You don't ever have to keep the inventory. You can just get them produced where you need them to be produced. This obviously though is dependent on being able to retain the intellectual property rights over your designs and to have secure transmission of how you share your designs. So big data and the sharing of files is something that these firms are thinking about. Aerospace and automotive are increasingly looking for ways to use additive, and a lot of the time you will speak to firms and they will tell you they're doing amazing things, but it's too secret and they can't tell you. Some of that I think is that it's important to be seen to be doing work around 3D printing. I know of one automotive firm who spent £1 million on a machine and supporting machines, 3D printers, had a big press fanfare. The press went away, they put it behind some doors, closed the doors and never used it. But it didn't matter because their share price had increased well beyond the cost of the 1 million they needed to buy the machine. So when I say we're thinking a bit more critically around the hype around 3D printing, it's quite hard to unpick. And it means you have to develop quite close relationships with these firms to get past a lot of the press releases that we're constantly seeing about industry and 3D printing and how revolutionary it is. Aerospace and automotive would have for some time been printing less critical things. So for example, the plastic trays on the back of a seat could be 3D printed, for the spare ones that were needed. But we are now seeing parts being approved for critical use in planes and cars, which is where we've seen in the last 3 to 5 years a real shift in confidence around the standards of the parts that are produced. What I would like to emphasise is that there is no overtaking of traditional methods by 3D printing. It's very much complementary. Industry repeatedly tells me 3D printing is a tool which is used alongside other tools. There isn't now in industry any suggestion of traditional methods being replaced. The bottom example is the seat for an Airbus A380. And this is designed using 3D printing, and the mold is 3D printed, but it is then produced using metal in traditional methods. It's cast. So we're seeing the two different methods coming together. So the 3D printing is facilitating this. That part used to be 20 different parts that were all bolted together, and now one single part is produced to make the seat. And that has provided significant cost savings over the lifetime of the aircraft in terms of the weight savings. The Airbus A380 is no longer in the skies as much and the orders have closed, but it's a very nice illustration of how these two things can work together. The example in the top is BAE Systems Eurofighter. They will set up a whole production line using a mixture of different methods, mainly conventional manufacturing, in order to produce, say, 30 fighters for the RAF. They may then have an order come in from Saudi Arabia who want 5. And the setup of the aeroplane has to be different. They want different range, they want different weapons, which changes all the insides, all the gubbins inside the plane. So the picture on the far right is part of the cooling system. And that part is 3D printed because it's not cost effective to change the production line. It's much more effective to just produce 5 of those using additive manufacturing to fit into the new configuration. So it's really supporting the production, the subsequent production, using a different production without using a whole setup new production line. So very much in complement. So I wish I had more to tell you about the third point about relocalization. It's what sparked my interest in 3D printing, the change in the geographies of where we produce. But we're still actually just seeing limits to changes to domestic production. There's not yet any evidence of things coming back from the Far East, even under COVID conditions. We're seeing some small-scale bespoke production and smaller production lines are more likely to remain in advanced economies rather than going to low-cost locations. But in the sense of bringing back quite a lot of manufacturing, we're not seeing so much of that. There are some concerns around, well, have we got the ability to do that manufacturing here ourselves anyway, particularly in the UK, where industry feels very neglected and underfunded for several decades. And the sense that Europe and the US might be leading at the moment in terms of 3D printing technology, but with the levels of investment that's happening in Asia, we can't be complacent that that's going to continue. And it might be that you go to Asia to get the expertise in 3D printing, which I hope not, but it's possible. And also we have to remember that things are geographically and sectorally uneven as well in terms of the types of things that can move or will move and where they've moved from and to. So to summarise, because I'm conscious I've probably gone over because I could talk all night about 3D printing, being a bit more realistic about where we currently are with all this huge rhetoric, the scale of domestic production is still currently limited. I think that we haven't seen the change in consumer practices that we would need for that to be more universal. 3D printing is a set of processes, not a universal process. So this is the first step in people realizing we know what we talk about when we're thinking about 3D printing, is actually there's multiple ways of different ways of 3D printing in a whole range of different materials, including biomedical. There are advances being made in speed, size, and the material for printing. And these advances around the materials is actually where quite a lot of the excitement is. Less about the nuts and bolts of how we 3D print, but is what we 3D print with, and getting to the point where we can talk about printing in multiple materials at the same time, which is where we could start to embed electronics in things while we're producing. I think the status quo of capitalism and the existing supply chains are really limiting the potential for radical and transformative changes. And I think that's what I was trying to hint at when I was showing you about how logistics companies are becoming interested in this technology. I didn't want to spend too much time talking about COVID-19 because I felt it would give us a slightly skewed perspective on 3D printing. But I do have some knowledge about what's been happening in the pandemic. So I thought I'd leave that up to the audience if there was something they're particularly interested in. And many of my answers will echo the picture I've already given you of 3D printing today. So I will then open up to questions. I've left just a blog piece that I wrote at the bottom about what it might mean for the workforce, and also this industry report that's quite heavy, but maybe even interest if you're particularly interested in industrial 3D printing. So I'll draw this to a close now, and thank you very much for listening.
Jennifer, that was excellent. Thank you very much indeed. I'm just going to take the, can you just unshare the slides? I've taken a screenshot of your last slide so people can then use that to contact the relevant bits and pieces. But once again, brilliant. I really thank you for giving us a very erudite tour de force across 3D printing, not just in terms of personal use, but also industry and the different types of facets involved. I think it's been fascinating, particularly, you know, it's not, from what you're saying, Jennifer, 3D printing isn't going to take over and change the world just yet, but I think it's a very useful tool in industry, especially even in design, even if it's not used for manufacturing. You know, it's in different stages of the process. It has a role to play and is making life easier. Now, we're now coming to the Q&A session, so we've got plenty of time left. As I said, you can now unmute yourself and show your screen if you want to ask a specific question. And now, Brian, you've got a question. You've raised your hand electronically and you've got your video open. So, Brian Snellgrove, do you want to ask the first question, please?
Price. You say about £2,000. I've just done a search on See Amazon 3D printers, and I get Flashforge $299, Anycubic $329, Flashforge $499. It seems far lower than you're indicating. Are these below your horizon of quality?
Yeah, I think it's very much you get what you pay for. I mean, if you wanted to give a child something small because you weren't sure how much time they were going to spend in playing with the technology, I think it entirely depends what it is that you want to do with it. I was looking to show you something that would give you kind of bridging over from producing something at home, but maybe an entrepreneur being able to use the Ultimaker. It's just of a higher standard that more people would be aspiring to buy to maybe do what they think they want to do.
Yes. Now, if I wanted to, this is boys' toys department. If I wanted to do a miniature head of myself, I imagine there's some quite good software sold with the machines. Would I have to photograph myself from many angles? How does it work to make a miniature head, 3D head?
Cura is the software that most people use, C-U-R-A.
Okay.
That's the one that people tend to use. You would have to take different photos of yourself, and then that would build up that 3D image for you, which would then be printed from the bottom up. The cheaper the machine, the more obvious gaps you'll see in the different layers. So the Ultimaker is quite good in that it's quite smooth. So the cheaper machines, you can see quite clearly where the different layers have been built up.
Thank you.
Okay, well, Brian, we look forward to seeing your 3D printed head at some point in the future.
It could be better than the original. You never know. Bit of Photoshop, you know.
It's only the important bit is always in the inside, Brian.
Yeah. Thank you for that spiritual enlightenment there.
Good. We've also got a question from Jackie. Do you want to ask that? Do you want me to ask that, Jackie Wilkins, or do you want to do it yourself?
Yeah, I can ask it. Jennifer, thank you for the talk. It's really interesting. Have you looked into anything to do with the construction industry, and particularly building mass manufacturing housing?
Actually, when I was talking about the Fab Labs, they've been doing quite a lot. They have various spaces, one of which is just outside Barcelona, where they've been using 3D printers to build up spaces using concrete, layers of different concrete. So it's quite often used as quite a showcase example of what the potentials are. How much that's grounded in the realities of what we're currently able to do is more question. what we are seeing is more of a tendency towards 3D printing being able to use in either extreme scenarios like disaster scenarios. So you have 3D printers that can go out and help form these shapes, not tents, but, you know, structures, shelters for people. Or also the use of the 3D printing in things like biolabs or spaces that wouldn't traditionally be square. So you want curved surfaces because you don't want germs to stay in corners, for example. So at the moment it tends to be quite specialized things, but I will agree with you that I think there seems to be quite a lot of excitement around the potential in construction. One of the limitations is the size of the machines themselves and what they're capable of building together.
I heard that in Saudi Arabia they built a 3-story building, allegedly. I don't know anything much more about that.
Yeah, I mean, we'll hear these examples. The question is always, well, how transferable is this? Was it a one-off to serve a particular purpose? The kind of, well, we can. It's always, well, should we continue to do so, and what would the advantages be?
Thank you.
Okay, well, actually, just to follow on, how long do you think this house would take in Saudi Arabia? A 3-story house would take how long with a 3D printer?
I don't know enough about the printer, so I won't be able to tell you, but yeah, a long time.
It's just, you know, the sort of public perception is that these things go up in hours, but obviously, you know, a 3D house that would take a significant amount of time.
Well, an example for you about time is you saw those dental implants. Yeah. You would get several hundred out of a build, depending on the size of the industrial machine, but most of them are within about a 30 centimetre or maybe up to 50 centimetre bed. That would take about 12 hours to print, but it would take 12 hours to cool.
Yeah.
And then they have to be post-processed, so they have to be taken apart by hand, and then, you know, filed down, made smooth by hand before then being used. So it's quick in the sense you're probably saving on logistics, but it's not necessarily quick in terms of how quick it is to produce.
No, absolutely. I'm just looking at the chat room. There's no more questions there. I mean, are there questions that people want to ask?
Question, my other half.
Yes, I would just like to ask, I come from an art background. I'm aware of how sculpture is made. And the thing that really would interest me is that the molds that are made for sculpture are now done in resin, and bronze or things are poured in to make the piece of sculpture. 3D printing could in fact make those molds much, much quicker to manufacture a piece of sculpture. I just wonder if it's been done yet.
Oh yeah, the art world is very enthusiastic about it. To the degree now, instead of talking about STEM, we talk about STEAM, because the art has come back in. Yeah, it's actually things like jewelry has been leading the way in some of the development, because again, talking about these small pieces, but yes, you're right, very much right. These very complex geometries very much suit that construction, and they would be used normally in a resin bed. So that's where you have a resin in a tub and the laser changes the properties of the resin and then comes out very space age. The only disadvantage is that resin is really very nasty and you can become very allergic to it. So it needs to be in the right hands. But yeah, the art world, I mean, there's quite a lot of things when you look now, I can tell that quite a lot of things are being made using 3D printing. They may not say they are, but many of them are.
Yeah, thank you.
Thank you.
Excellent. Sounds like we have to put Mr. Milkinson in touch with Brian and the head. We've got, again, you always come up with an iPad. I still don't know your name. What is your name?
Duncan.
Duncan, you've got a question.
Yes. When you showed the diagram, which I'm afraid was too small to read on my iPad,
Right.
But you had all these different types of additive manufacturing. Some are for plastics and some for metals and so on. But as technology gets more sophisticated, and you were saying that eventually people will be able to print things that have different materials in them. Presumably that technology will consolidate. Do you think the manufacturing of iPad machines will consolidate into a few dominant people, and there won't be specialists in one and specialists in the other, and there'll be just a few big iPad, sorry, not perhaps it was me, a few big additive manufacturing companies manufacturing the equipment to do do additive manufacturing.
Yeah, that's a really interesting question. There is a lot of consolidation with the industry at the moment because it's so fragmented. But such is the degree of expertise that is needed in each of these different technologies, and they're each racing to improve, that they've still remained quite distinct, because you can imagine there's quite a big leap from a pool of resin with a laser in it to powder with being built up over layers. So such is the difference that it's probably it's not a silly thing to ask at all. It's just, I think,
oh, good.
No, not at all. And it's what the industry is asking themselves as well. But I think at the moment the degree of engineering specialism is too great, and that each process will try and use different materials within that process rather than crossing different processes. And the big question is, a lot of the 3D printing services are getting bought up by the big companies. So companies like the car manufacturers, the aerospace industry are potentially going to buy the 3D printing machines and have them in-house. So there could be bigger changes ahead in terms of the structure of the industry. It's maturing, but it's by no means stable. So I think the sense is that our experience of it is probably dictated by what happens at that industry level.
But Duncan, that's a very good question, Duncan. And if people are interested in that slide that actually show all the different technologies, then if you Google 3D hubs, additive manufacturing technologies, and click on images, you'll find it very easily there. So again, I've put that in the chat. So if people are interested, you can look at it there. Brian, you've got another question.
Yes, final question. I get the use of plastic, but if you've got any quasi-metal, that's got to be of a lower melting point. How can it be used in industry? You want the old tough steel, don't you? I mean, it's just plastic metal, isn't it? If you want to replace metal.
Yeah, so the question, Jennifer, is do we use molten metal to construct 3D images, or is it literally just a sort of resin of some form, like the dental implants? And
they're printing in titanium, in different metals, which are obviously tested. The issue with 3D printing is that when you print with it, you're not as easily able to test the properties because it's being printed layer upon layer and you don't know what's going on in between those layers. So there's a whole now associated industry, which is X-raying, CT scanning, finding different ways of measuring the properties of those prints because they can come out differently. So I remember talking to a Formula One team, and that funny bulge behind the driver's head in the car where a lot of the exhaust comes out, that's also a really important protection mechanism, and it's traditionally cast in metal and is very, very heavy. So this team took it upon themselves to print a version because they knew it could be a lot lighter and it'd be hollow. But they didn't know what was going on in the print of the metal. So they printed 5, and the first one was perfect, and they loved it, and they celebrated, and the following 4 all failed, and they didn't know why, which put the team off 3D printing for several years before they came back to it. They still not found a way of printing it. But this speaks to some of the uncertainty around what happens when you print and how you measure. Because if you produce something on a traditional manufacturing line, you test occasionally, but the process is the same, so you can make assumptions about what's coming out at the end. With 3D printing, that's not the case. But metal printing is overtaking plastics in terms of the scope of what you can make using metals, is far more interesting to industry than plastic at the moment. Plastic was further ahead, but metal has caught up. So much of that is around standards and how we make sure what is happening in the right ways. But there's also things like covering the plastics, using alloys to cover what's printed. So again, this complementarity with the traditional methods is industry, 3D printing industry is constantly telling me a lot of the problems they have the answers are existing in traditional manufacturing. They just need to apply them. So yeah, very much a lot of knowledge sharing between. 3D printing isn't sitting on its own.
Okay. No, that's excellent. I mean, the question I suppose Brian had is, at what temperature titanium, for example? I don't have no idea. I'm not a scientist in terms of what the melting point of titanium is, but is it printed in its molten state, or to actually create?
Yeah. So you have a bed of powder. So the powder is produced by specialist companies.
Yeah.
So it's traceable, so they know the quality of that powder. And the whole bed, imagine a big square cube like this, is full of powder. And then they'll start at the bottom, and very high power lasers, either one laser or a £500,000 machine will have 4 lasers, so it goes at 4 times the speed, will then laser at particular spots, which will melt the metal, and then they'll come up a layer, and then they'll come up a layer, come up a layer. And when the print is finished, the excess powder falls away.
Yeah. So I think that answers Brian's question. Good, excellent. I'm not seeing much more activity in the chat room. Does anybody else want to ask another question before we close for the night? No? Okay, well, in that case, it just remains for me.
Sorry,
Oh.
I've just joined. Can I ask a question?
Yes, of course you can.
I'm sorry, I've missed most of it. I do apologize, but my basic question is, when you're creating different things, you need different materials. So I'm not sure if I missed out on that conversation on that bit. So what would be the material used for different things? For example, airplane parts would be different from a tabletop printer, for instance.
Yeah, you can print in a whole range of materials, so ceramics, metal, plastics. So if you've got a large producer, say Boeing or BMW, in their factories, they'll have a whole suite of different machines from different 3D printing manufacturers printing in different materials.
So basically, it's a worldwide activity. Production can go just grow exponentially just based on 3D printing.
Well, yeah, we haven't quite got the speed or the capacity to produce in volume. So that's the big question at the moment, is how to compete with the ability of, say, injection molding to print 2 million of something. Sorry, to make 2 million of something.
Quick question about the ceramics. Because ceramics is used, you use clay and you mold it. How would you do 3D printing with ceramics? I mean, with a powder, basically. How would that work?
I'm not entirely sure, because I've heard of the machines and they're not very widely used in industry. They're used a bit where you need the properties to have the heat protection. So you might get some parts on a Formula 1 machine. The only one I ever saw wasn't being used, but I'm not sufficiently knowledgeable about the engineering of that. So apologies.
No, that's fine. Good. If there's no further questions, I mean, it might be really helpful because normally we obviously show our appreciation in the normal way for speakers who've done a fantastic job, which you've done, Jennifer, tonight. So thank you for that. Maybe we can unmute ourselves and give Jennifer a round of applause for today's lecture. Okay, that's excellent. We've even got some virtual claps on by people, which is great. So
thank you very much, everyone.
I've emailed mine in.
Excellent. So Jennifer, I think that once again, thank you very much for the excellent presentation. And would you mind sending the slides to me? I can then send them on to the group. Would that be okay?
Yeah, absolutely.
Really interested. And obviously, the actual presentation by video will be available on the BRLSI YouTube channel on probably at the beginning of October, in about 4 weeks' time. So you'll be able to see it on the virtual BRLSI YouTube channel as well. The only thing for me to sort of mention, I suppose, is next month we move on to another topic, and we have Professor Agnes Nairn from the University of Bristol giving a talk on gambling and children, the next impending crisis. And clearly, she's going to make reference to things like online gambling during lockdown as well, and things like that. But also the impact it has on children and the access children have to online gambling. That's on the 13th of October, and I look to see you then. So all that's left for me to do is the usual goodbye, which is stay healthy, stay safe, and stay sane. I'll see you next time. All the very best.
Thanks,
Bye,
bye.
everybody.